Hey everybody, welcome to How to Enhance Your Application Security Strategy with F5 on AWS. I'm Nick Matthews, I'm a Solutions Architect here with AWS, and we're also joined here with some F5 folks, so Dave Morrissey and Nathan McKay. We're going to talk later about some of the F5 specifics on AWS. So the topic for today is really security, and we're going to start here with this quote from Gartner. This is from a Gartner report called "Clouds Are Secure. Are You Using Them Securely?" And the quote here is basically saying that for since cloud has been around, security has been the biggest question. It's job zero here at AWS. We care very deeply about security. And one of the challenges we have with customers is there's this sort of large conversation that, like, is the cloud secure? Can I use it securely? Is it, am I going to be hacked if I use the cloud? All these sorts of questions. And this report is really good because Gartner basically says, like, you should stop worrying so much about that because, they've heard through their customer testimonies, the CIO of Capital One, 2 years at reInvent said they can operate more securely on AWS than they can in their own data centers. That's coming from a bank running in AWS. And so we've gotten to a point now, I think, in market maturity for security that people understand that, like, the cloud has controls and cloud has visibility and you can actually run more securely in the cloud than you can run on premises. And that's been a big change in mindset, and we're still working to help other people understand that. And so we're going through that here a little bit to kick this off. So why is security really hard? Well, I mean, security's got a couple different components to it, right? You need to know what's going on, and you need to know how to fix it, right? It's two-step process. But at least on premises, that lack of visibility on premises can be very hard because you have a whole different sets of solutions from all different sort of eras of your IT journey. Those may not have APIs. What is going on? Who put it there? How did that malware get in? What did it touch? All of those sorts of problems are really hard to do whenever you don't have visibility. And also automation. So if you don't have the API, so you may have seen the visibility, you may know what's going on, but being able to go actually change it or prevent it or monitor it at scale is really, really hard to do without automation. And so that, from a security perspective, we think those are two of the biggest problems that we can solve at AWS. So some of the components we have that make our security so strong, one is just the sheer scale of AWS. So, we run 14 different regions with 55 different availability zones, and some of those availability zones have 300,000 servers in them. And so we have just this massive scale that we can dedicate teams to cryptography and to, physical monitoring and security of our data centers and all sorts of security things that we can do at scale because we're so large. And because we care so deeply about security as well as our customers. We build things natively with security. So our APIs, for example, are encrypted by default. When we build new services, we make sure that we build them securely. So, for instance, like IoT is a place where it's very easy to scrape by with little security. But when we built our IoT service, we use secure certificates and over encrypted channels and those kinds of things. And there's certain sorts of security problems that also can be fixed when you have that sort of elasticity of scale. So, like denial of service attacks, we've obviously, being a cloud provider, we've seen a massive amount of denial of service attacks, and we have services and infrastructure built to protect you from that, but also allow you to auto scale if you think you should do that. In addition, and sort of why F5 is on the call with us today, is this ecosystem that we've got around security. So we're releasing more security services like GuardDuty, and at the same time, we've also got folks like F5 that bring on their platform that extends what we can do natively inside of AWS, and maybe that's good for your migration or to go further into the cloud. So if we see some of the designs that we're working with, one of the things is about data residency. So a lot of people are very particular about their data, and they should be. So one of the rules we have at AWS is, even though we have 14 regions around the world, your data will not leave your region unless you tell us to. So if you're in Germany and you don't want your data to leave the Frankfurt region, it will not leave the Frankfurt region unless you specifically configure us to do that for you. We've also got things around encryption at scale. So our key management system, our KMS, it recently got FIPS 140-2, so that's enabled a lot of customers to be able to use either their own keys or Amazon-generated keys to encrypt services like Dynamo and our file sharing services and your data at rest. And so we've got strong encryption that we can apply to a growing amount of our services. And there's also things like GDPR and what we need to do from a compliance perspective. So if you log into your account, you can pull down all sorts of compliance documents, whether it's FIPS or it's HIPAA or PCI, NIST. Those types of docs are in your account, and we can show you how we're meeting all those sort of compliance controls that you're already doing in your on-premises data center. You don't have to take my word from it. So we've got a lot of customers that have strong stories around here. So FINRA, who does financial regulations, and they need to be able to, one, process a massive amount of data, but two, do it and meet all the different financial regulations. Folks like Slack, that I personally use, they've got lots and lots of customers and all sorts of data, so they need that agility, but also need to make sure they can tell their customers that that data is secure on their platform. And folks like DNA Nexus, who do in the healthcare and life sciences space, that can do, they do genomics, so they're sort of in that same scale of they need to do massive calculations on sort of genomic analysis and those kinds of things, but also still meet all the HIPAA requirements and other healthcare life sciences requirements related to processing data. So if we get a little more specific about what we're talking about in terms of security, today the subset of security we're talking about is the Web Application Firewall. So it's super important because a lot of the applications that we see on Amazon Web Services are web applications that sort of the new modern way to build applications. And the Web Application Firewall is specific to protecting certain types of web applications. So we're seeing needs for more visibility, people that want to get protection from OS top 10 and SQL injection sort of attacks. And one of the reasons why we built our WAF is because we wanted to have a WAF out there on the market that you could get with a couple of clicks, that was super simple, that you could build into your automation and pipelining. So if you're doing continuous integration and continuous deployment, some of the DevOps sort of workflows, you want to be able to build your WAF into that workflow. So we've done that. And we also want to do it, at a very cost-effective price point so that you can get started and secure. We don't want cost to be the reason why you're not secure. So, we made sure that our WAF came in at a very low price point. And so that's sort of our WAF. It's it's from a rules perspective, from a functionality perspective, it's pretty simple, which is part of why we're here with F5 today, because they've got ways to extend our WAF and get into some more detail there. So with that, I'd like to introduce Dave Morrissey from F5.
Hey, great. Thanks, Nick. That was a really good introduction to some of the challenges in cloud security and how AWS can help customers to address them. Again, I'm Dave Morrissey. I'm responsible for F5's global partnership with AWS. And with all of the high-profile public breaches in the news like Yahoo, Equifax, even the IRS, now more than ever, it's important to consider how to best protect your applications. So before Nathan steps through some specifics on application security in AWS, I'd like to provide a quick introduction to F5 itself. So F5 is a little over 20 years old. We're based in Seattle, which is conveniently about 10 minutes from AWS headquarters, and we support over 20,000 customers globally. The two core solutions, Application Delivery Controller and Web Application Firewall, are both considered industry leaders. So F5 has the distinction of not only being recognized by the industry analysts as a leader, but also being recognized by AWS as a leading partner in application delivery and security. So due to this high degree of application protection, F5 is used extensively in large enterprises. This includes 49 of the top Fortune 50 companies, 14 of the top 15 US banks, and 15 of the top 15 US government cabinet agencies. Odds are very high that if you're a mid to large enterprise, there's an F5 solution protecting some of your applications. So the combination of F5 on AWS provides customers considerable flexibility in intelligent application protection. So some of these benefits include deep packet inspection filtering, and protocol compliance at the network security level, consistency in security, authentications, and operations in application delivery, the ability to leverage a common multi-layer environment intelligence to map metrics, app dependencies, and location in a hybrid cloud environment, determining who, how, and where apps are accessed to meet compliance and remote authentication requirements, and providing the same comprehensive level of security for applications delivered over HTTP. So this brings us to the handoff point to drill into F5 application security on AWS specifics. But before we bring Nathan on, I'd like to leave you with a few things to consider as you develop your own app security requirements. So one, the ability to deploy any app anywhere with consistent services and security is extremely valuable from an operational and compliance perspective. Two, leveraging proven technology is critical. So just good enough is not a security strategy. And three, working with an application security partner that offers flexibility and natively integrated cloud solutions provides you with the flexibility necessary to customize and right-size your security by specific application requirement. So with that, I would like to introduce Nathan McKay, our Security Solution Marketing Manager, and he will jump into the specifics on application security on AWS.
Awesome, thanks, Dave. All right, cool. So before I got started, I wanted to kind of give you all some context and background information on, why we think WAF is really important. And, some of this you're probably already familiar with, but if you're not familiar with F5, we have a research arm called F5 Labs, and they publish just like actionable threat intelligence. It's totally vendor agnostic. They just kind of talk about stuff we're seeing out in the wild, different threat vectors, different attack vectors, and they also publish a bunch of these cool reports. One of the more recent ones that we came out with was one we called Lessons Learned from a Decade of Data Breaches. And so in this report, the F5 Labs team catalogs approximately, it's 433 cases total that they catalog. These are confirmed data breach cases where we were able to look at some historical information like root cause analysis and all this good stuff. 338 of these cases that we looked at had confirmed breach quantity records. That means like we were able to figure out how many records were stolen and by, potentially by whom. But long story short is, this is a massive amount of research that was done across 27 countries, 37 industries, and so we saw some really good representation from just about every vertical. So one of our big takeaways here is that we had two really big numbers that I want to throw out there, and we'll come to those in a second. But what we found was that when we looked at the root cause analysis of all of these breaches, what was the initial vector or mechanism that allowed the attackers to get their foothold in the network? It was vulnerabilities in applications, and application level services accounted for 53% of those cases. And then 33% of them could be tied back to identity and access management related issues. So those could have been leaked credentials, breached admin credentials, mismanaged ones, etc. So I wanted to throw out those numbers, 53, 33. We're going to come back to those in just a second. So moving on. One thing, we talked a little bit earlier about the cloud security model, right? And how companies like Amazon and AWS specifically have done really awesome work to make sure that they have the entire cloud infrastructure buttoned up and locked down. And that's great and all. There is some clarification, and we get some questions about this fairly frequently about, okay, well, what does that mean to me as an application owner running my apps in the cloud? Do I inherit all of that security? And well, the answer is yes, and it's also no to some degree. We're like, yes, you get to inherit all of the security that's put into the infrastructure to protect it from threats at those levels, but by default and natively, you don't really inherit security controls at the application layer, right? So if I throw out, if I put a web stack on AWS, then I know that the infrastructure the hardware, the underlying networks that my apps run on, those are all very tightly secured, but the application itself, I'm responsible for. So let's take a look at this diagram that we have here. We talk about this idea of the shared responsibility security model, where an organization like AWS, they are securing the compute, they're securing the storage, the networking, the availability zones, the regions, and all of that good stuff. But there's kind of this demarcation line where above that, things like the app services, access layers, TLS, etc., those are all things that the customers themselves are responsible for maintaining and securing. So I want you to kind of bear that in mind here. Now, a second ago, I talked about this idea that we keep seeing, this massive percentage of breaches happen at the app services layer. So 53% is the number of cases we saw where we could attribute a root cause breach. And so again, this is a huge number right here. It's something that we can't ignore. Now let's throw up our other number there, 33%, right? Again, both of those are things that you as an app owner are responsible for maintaining. Those exist within your area of responsibility, this big 86% number. So tools like WAF, we find, are great for helping customers manage those types of risks because they're numerous and they're many, as we'll see here in a second. So keep that in mind. You definitely inherit a very positive security model from AWS, but the application security is something that you must take into account. So what are some of our challenges when we're dealing with these types of problems? Well, application layer threats, they're becoming increasingly sophisticated. We use HTTP for all manner of applications and different types of traffic. There's different versions. We have things like WebSockets. There's just a variety of different attack vectors. So HTTP is super complex, and the threats are becoming increasingly sophisticated. So we need to bear that in mind. We also need visibility across our entire application security services, right? So as I think most people are pretty familiar, there's been a massive uptick in deployed and SSL-enabled services across the internet. In fact, I think it's more prevalent to find encrypted services than non-encrypted ones anymore. And that's great, but it does introduce a new challenge in that if we're maintaining or responsible for maintaining an application that processes traffic that's initially encrypted, that comes in over a secure channel, which it should, we don't have visibility into that unless we're doing the decryption. So tools like WAF can't really function effectively unless they have visibility into the actual HTTP requests that are being received, and also being able to analyze the HTTP responses. So being able to evaluate the session in context. So visibility is obviously very key. Tools like WAF just can't function without it. We know that a lot of our customers and people out there they have regulatory requirements they have to meet. So things like Sarbanes-Oxley, PCI, HIPAA, GDPR was already mentioned. That's coming into effect, I think, here in May for our European counterparts. But it's undeniably an aspect to the equation. But what we like to try to make sure we're getting across to folks is that regulatory requirements is kind of the the lowest common denominator, right? It's the baseline that you have to meet. It's adhering to your requirements is great, but it's not necessarily going to get you a positive and proactive security posture. We really need to go beyond that. But it is a consideration that most of us have to take into account. And as was mentioned before, security can be expensive and time-consuming. And what I'm going to talk about here a little more in a second is this idea that it's not just expensive and time-consuming for the security practitioners who are reacting to incidents etc. It's very expensive for web application development teams, right? We know there are a myriad of attack vectors. The OWASP Top 10 outlines just a handful of them that, you know, they're tough problems that dev teams have to contend with. And dev teams really only have a limited amount of time and money and energy. They need to get apps shipped and out the door and into the marketplace as fast as possible. And that's where tools like WAF can really come into play and really shine, is to help ease that transition, to make sure that you have mitigations in place and that you're not coding them into the apps over and over and over and over again. Again, it's a very expensive process for development teams, and that's where we really think you know, solutions like the F5 WAF can definitely help you guys out. So let's keep that in mind. I'll go ahead and keep moving here. But ultimately, what are we trying to get to, right? Like, we talk about security all the time, and I like to kind of back off a step when we talk about security, but because a lot of security practitioners, they kind of get in the mindset of, hey, we're doing this for security purposes, and you're really not. Ultimately, when we engage in any type of security program, we're trying to maintain business continuity. That's the reason we're doing it. You know, we need to be able to maintain and grow revenue. We have to identify industry threats and be able to respond to them. We have to protect our assets and customers. Ultimately, again, when we boil it down, it is about ensuring a proactive posture in order for our companies and our organizations to continue to thrive. That's why we're doing it. So that's especially important when we start talking about cost and pricing and balancing all of those factors with these you know, proactive security models and that we're trying to espouse here. So again, the kind of takeaway, we talked about this a little bit, but I want to make sure that it's perfectly clear, is, you know, tools like WAF can stop and block these types of attacks before they reach your apps. That's what it's there for. It is a secure and expedient and very effective way to make sure that you're filtering out bad requests from bad actors that you don't want, and that you are allowing the right traffic from the customers that you do want. You know, what with all of the automation out there on the internet today, we know that there's a massive proportion of traffic and requests that, you know, really everybody's seeing that's just not wanted. It could be like scanners that are looking for vulnerable systems to add them to botnets, and it could be, you know, like scrapers, people looking to harvest intellectual property or pricing information. Really just there's this huge variety of customers, or not customers, but rather users or entities that are probably visiting your site on a very regular basis that really will have no positive impact to your bottom line down the line, right? They're not going to turn out to be customers. They're not going to buy later. They are looking for an opportunity to leverage your infrastructure to their own gain. And we see this more and more these days with the whole cryptocurrency and crypto mining that's going on, is people are compromising systems merely for the purposes of harvesting their CPU time. And that's especially critical in environments like AWS, where you are paying for that CPU time, right? So definitely some really interesting factors to keep in mind here. But ultimately, yes, WAF can help you block and filter out the types of requests that you simply don't want and have no use for. So I'll give you kind of an example here. We talked a little bit about inspecting application traffic. The visual example here we use is like SQL injection, right? And the reason we talk about SQL injection is because it's still a thing, right? We're still talking about it. It's a very well-known attack vector. It is, so just this past year in 2017, the OWASP organization released a new version of their OWASP Top 10. Now, on the previous version of the OWASP Top 10, there it was, injection, SQL injection, right up front, the #1 risk area. In fact, when we go back to our F5 Labs research, when we start breaking apart all of the different attack vectors, I said that 53% of those breaches could be tied to application vulnerabilities. Well, breaking that down further, half of that number, so a full quarter, could be attributed back to things, to injection-related attacks, right? And this is still 2018, guys. So again, going back to the OWASP Top 10, the previous version of the OWASP Top 10 had injection right up front, number 1. 10 years later, we get a new version of the OWASP Top 10. Guess what? Injection, SQL injection, the number 1 risk area, right up front, right? The very first thing. And that's not because we don't understand it. It's not because it's this big elusive problem. We're still dealing with it, and it's still the number 1 risk area because it's a tough problem to crack, because it's difficult to defend against, and because it's difficult to build apps in such a way that they can be dynamic, leveraging databases and all of that good stuff, but that they can also be defensible. So again, this goes back to the idea that building these types of controls, like mitigations for SQL injection, into every app over and over and over again, it's just costly. It's difficult to do. So that's why we're still talking about things like SQL injection in 2018, because we just haven't got a handle on the development aspect. But again, tools like WAF can help us bridge that gap to look for those types of requests. We don't have to build those controls over and over again. We just inherit them from our security services. So it's a great way to position your dev teams for more expedient success. Another problem that we see all the time is dealing with, software vulnerabilities. So new vulnerabilities are discovered in all manner of software all the time. This just isn't going to change. In fact, if we look at the chart here on the right-hand side of the screen, this is a listing of the total number of reported CVEs for the past 7 years, right? And we can see this marked, uptick, this trend. There's a little bit of a dip there in 2016. But in 2017 alone, we saw approximately 11,000 CVEs reported. So common vulnerabilities that were reported in a variety of software. So that 11,000, that's not the total number. That's just the number that was reported in 2017. So then we've got 8,000 in 2016, approximately 9,000 in 2015. So we've got this huge set of cumulative vulnerability that we have to deal with. And again, this goes back to the idea that, developers reuse software components. They do this all of the time. It's part of just building apps with building blocks and getting them shipped and out the door. So very frequently, dev teams find they need a particular version of something. And then ultimately, once that app gets shipped, the people who are responsible for maintaining it will see some level of risk in trying to upgrade all of those dependencies and maintaining the entire stack. It's got to be done for sure, no matter what. We really can't get around that. But tools like WAF can help give your operations team the zero-day breathing room that they need. They can help filter out the types of requests that will exploit known vulnerabilities in software stacks and keep them protected while the ops teams can go about their business to run their change management programs and get new versions of the app built and tested and shipped and out the door. So there's some really good opportunities here, and some definite factors for why we continue to see these types of problems. So what's the other big thing that we keep hearing about more these days is analytics, business intelligence. Data is the new currency, right? If we keep hearing this number bandied about that, round about half the traffic on the internet is automated, right? Well, are you taking that into account, or are your marketing teams taking that into account? Are your business intelligence folks taking that into account when they start looking at statistics and trying to evaluate who is visiting your sites to try to get the most effective data? Because if they're not, then how accurate or relevant is that data? How valuable then is that data, right? If you're not taking into account the fact that a large percentage of those requests are bots or scanners or just non-customers, you might be basing business intelligence decisions on bad data. And so ultimately, yeah, we see lots of people monitoring their traffic analysis, to try to figure out customer buying patterns, customer shopping patterns. And yeah, we need to make sure that we have actionable intelligence, that we can identify customers from bots in order to make that data ultimately valuable. Yeah, you've just got a lot of noise. You have ephemeral requests, lots of bots and scanners, so it's a big problem. But it's something that really has to be espoused to your customers and stakeholders, right? So as security practitioners, that's something that we know and we can have a pretty good handle on. But a lot of, like, say, the marketing folks and the business intel folks, they're used to seeing certain numbers on their sites. So what we found in practice, and this has been reported to us a number of times, is that, security teams, ops teams will go in and say, hey, we need WAF, we need to be able to protect against these various risk areas, bots, vulnerabilities, et cetera. And they'll bring in WAF, and the marketing teams aren't prepared for the types of drops in requests that we're seeing. They'll see drops due to the fact that we started filtering out bots, and they think that tools like WAF have all of a sudden started blocking their customers, and that's really not what's happened. What's happened is we've both started blocking their non-customers, and we have actually helped enrich their data, right? They're going to have more actionable, more valuable data because the data that they are getting is their real customers, their real prospects, et cetera. So it's something that definitely needs to be couched to the right folks. Okay, so how does WAF work? Let's dive into that a little bit more. We talked about WAF being a great way to improve your app security posture quickly and easily. And we would still argue that's the case. But ultimately, web application security on the whole, it can be complicated. There are just so many different attack vectors, right? Just between SQL injection and cross-site scripting, there's so many different ways that cross-site scripting works that it's just tough to handle, right? So tools like F5 WAF can give you substantial security out of the box, doing things like just identifying and challenging bot-related traffic. And again, the big takeaway here is to help your security teams focus energy on the critical tasks and not deal with, just minor incidents all the time, but to also, again, get your development teams more breathing room and get their apps to market and earning revenue that much faster. So how do we do that? Well, first, we need to block known bad requests, right? This is both easy and tough because there's so many different bad requests. A blacklisting policy by default is not really the right, that's not going to get you everything, but there's plenty of stuff that we just know is fully bad requests, that things that attempt to evaluate or that attempt to exploit things like SQL injection, command injection, cross-site scripting. There's plenty of known evasions and encoded attacks, things that try to bypass WAF controls that may not be robust enough to unravel them, per se. We also need to stop talking to bad bots. So F5 WAF technology can help you identify and challenge malicious bots. It can also help you block malformed requests. There's lots of friendly bot imposters and other tools that attempt to exploit various vulnerabilities in order to, say, do things like drop malware onto your sites and use them for their own attacks later on. So F5 WAF can help you actively defend against bots and do it in a proactive fashion, right? We also need to stop talking to bad IPs. We know that there are plenty of compromised systems or malicious systems out there on the internet that are running nonstop scans, that are participating in botnets, command and control infrastructure, hosting malware, hosting phishing sites. So, smart tools like F5 WAF are going to have both things like geolocation, in case you have geolocation related problems, or having the right IP intelligence, so reputation, all of that good stuff that can help just stop accepting any requests from just known bad endpoints. There's lots of classification that we can do here, so there's some pretty fun stuff. We can also hide details that nobody needs, right? Really the first step in conducting any type of breach is doing reconnaissance, right? And doing reconnaissance involves figuring out what types of software stacks our targets are running. So in this case, we've got this highlighted value of Apache 2215 with PHP 5432, right? This is all data, information that a lot of web servers leak or divulge by default, and it's done in the headers, it's done in the page metadata. There's just a variety of ways that this stuff is leaked, and ultimately it's not stuff that your customers need, right? So if you're not familiar with Shodan, the Shodan search engine, I definitely suggest you kind of look into that. But Shodan does this for people, right? It goes out and just catalogs the internet. It looks for who's running what information they're divulging, and attackers use tools like Shodan to help make their reconnaissance more streamlined and more effective, and make their attacks ultimately more expedient. So it's a great way that they can avoid having to hunt and find vulnerable targets when they can just query search engines for that information. But again, the search engines won't have that information if we're filtering it out before it's published. So again, this is just a great proactive, preemptive step to make sure that we're not giving out more information than necessary. We also need to hide or mask sensitive data. So tools like the F5 Data Guard, which is part of our solution, can look for and filter out data in the responses from your servers back to the customers. So this could be things like credit card numbers, account numbers, social security numbers, custom defined fields. It's kind of really up to you, but it can help to prevent loss, and is a great way also to identify successful exploits. So let's say that for some reason a SQL injection was able to be exploited. Looking for data in the responses can help your security teams identify those problems. Because really, ultimately, it's about seeing the hostile traffic. You're going to also need this level of visibility to figure out, hey, what parts of my sites appear to be vulnerable, what are being targeted, where can I do more filtering, because attackers will ultimately try to find these holes. We've seen plenty of cases where an attacker will try to target what we call a heavy URL, or one that results in lots of back-end processing through your database, et cetera, in order to cause an outage, like a denial of service. So being able to see where those requests are hitting is critical to building and maintaining active responses. And as I talked about a second ago, this goes back to L7 denial of service attacks, right? So ultimately, F5 WAF in this regard can help protect you from DDoS attacks by continuously managing app performance and tracking these URLs for utilization and resource constraints, blocking bots that are attempting to hit and impact performance of these critical resources. But ultimately, yeah, it's always on denial of service protection. Okay, so moving on, getting to kind of some of our wrap-up information here. F5 WAF technology is more accessible and more affordable than ever. We've got a number of solutions available in AWS, and really it's super easy to acquire and implement in your environment as a result, as some of our previous folks alluded to. We've got flexible and expedient deployment options, right? So you can run F5 WAF solutions that are about any size and readily available to defend apps of any size and variety. So as was previously mentioned, our WAF policies are portable and reusable. That means you can use them anywhere in AWS. You can use them, you can develop them in one availability zone and migrate them to another. If you have on-premise solutions, if you have F5 WAF on-premise, you can build your policies there and deploy them in AWS, or vice versa. But ultimately, the key takeaway is being able to have a unified process and unified controls, unified comprehensive security controls is really going to help make sure that you have the greatest degree of coverage and that you're not spinning your wheels building these controls over and over again. Again, this is very costly to do for development teams, and it's very time consuming. So F5's got dedicated teams of researchers and engineers doing this heavy lifting, right? Like, we have people who live and breathe this stuff all day long. Dedicated research teams that are constantly monitoring active data flows and are able to continuously enhance the quality of our rules. We do have comprehensive OWASP Top 10 support, but again, I want to remind people that the OWASP Top 10 is just the top 10, right? It's just the biggest ones that, we've seen be continuous problems. It's not comprehensive protection for your application. It does not address things like denial of service. It does not address things like intellectual property theft. It does not address things like fraud. So be sure to, so when you're evaluating WAF, you really need to make sure that that's kind of a baseline consideration and that your WAF is capable of helping you address all of those other risk areas that I just talked about. So yeah, as I mentioned, we've got great effective protection against threats beyond the top 10. And then, yeah, it's an awesome solution. So we've got a number of common use cases for F5 WAF on AWS besides like just the really, advanced threat mitigation. But we have like high availability, right? You can run us in a variety of HA configurations. So this is in many ways traditional or akin to traditional on-premises HA. And yeah, it's a great way to make sure that you have just complete availability from your app for your applications within your availability zones. And so one of the other solutions we want to kind of highlight real quick is, in addition to our comprehensive WAF and advanced WAF, we also have F5's managed rules for the AWS WAF. So what this is it's rules that are developed by F5 security teams. So they do provide a number of value in a number of different ways, but there is still some limitations with what we can do with these types of rules, right? Blacklisting just isn't the only way to go about this. It's not a 100% viable security strategy, but this is a great way to get up and running with WAF and to get up and running quickly with some really smart rules. So this is a pretty easy process. Really, you just have to go to the AWS Marketplace or the AWS WAF console, discover and subscribe to our managed rules, and then associate those rules with your AWS WAF. So, but yeah, I wanted to kind of touch base real quickly on some of the differentiation points. When we talk about traditional WAF versus F5 WAF and F5 advanced WAF, in traditional WAF, we kind of see this support for most of the top 10 usually. We get some SSL TLS inspection usually, because obviously we need that in order to see the HTTP requests. And we typically get blacklisting. But blacklisting only blocks against known bad vectors, right? And as we saw earlier, we've got new vectors being developed all of the time, attackers coming at us in a variety of new ways. So blacklisting isn't the most effective way to go about this. In F5 WAF, we've got all of that same stuff, plus quite a lot more. Things like proactive bot defense that can help identify malicious bots or even benign bots, right? Like, let's not forget about the wanted bots, things like search engine crawlers, or, the kind of customer-facing and customer-centric automation that we're starting to see with digital assistants, things like that. We've also got some really awesome coverage for credential-level attacks. So if you're familiar with credential stuffing, that's a term we use for this idea where attackers, they go out and they purchase or somehow acquire databases full of stolen credentials on the internet. And because users reuse their passwords across a variety of services, I mean, who can blame them? They're dealing with so many. Because they reuse those, then a breached password at one site can ultimately become a vulnerability or a risk at an unbreached site. So quite possibly a number of your customers are using the same credentials that they use elsewhere, and there's a real risk here of the misuse and risk of these attacks. We don't really have too much time to dive too deep into that, but I want to make sure that it's called out. We also have some API level attack defenses that are super handy and are even more critical these days when we start talking about like mobile applications and services that leverage APIs. So some kind of additional considerations here. Managing vulnerability, it's just one piece of the application security puzzle. So apps and vulnerabilities constantly change, as we saw with the year-over-year CVE increases. But ultimately, yeah, we need to go beyond vulnerabilities and pursue an active and proactive security posture. Good security tools can help reduce costs and give us better business intel, but ultimately it's on us to push to make security part of the organizational culture where we work and to become partners and enablers to the business as security practitioners. So what are some of our key takeaways? Again, we saw some of these already, but yeah, F5 can help you run smarter, faster, and safer in the cloud. Again, we've got consistent security policies that are portable across, anywhere where you can run F5 security solutions. So on-premise, in the cloud, wherever. They're great ways to give you better management and visibility into your application. Workload migration. This is, again, the portability goes into this. It's pretty key to the workload migration aspect of it. But yeah, we can easily scale our security with these types of tools, and they should ultimately help you lower your total cost of ownership, right? We talk about being able to filter all of these unwanted requests we're seeing. And if we're unable to do that, then that's cost that we incur in our VPCs, right? Processing unwanted traffic is going to cost us money. So tools like WAF can help us manage that. All right, so I think that's pretty much what I had. We can move on to questions. I'll pass back control.
Cool. Yeah, so we've got some questions here as we've been going on, and we've been answering some of those. So Nathan, I know one of the questions that came in, does this solution in sort of the whitelisting blacklisting use any ML or AI?
So there is some machine learning that's done. Some of it is inherited from the research that we've done. In the F5 solutions, yes, it is much more active because we have full appliances. There is some being done. Don't know if I would go so far as to use the AI catch-all, but you can learn more about like our risk engine and the decision-making process that's built into the technology. It's a pretty deep topic. So I will say, yes, there is some machine learning that is being done, but as you know, with any response, that could be qualified a little bit further depending on what your requirements are.
Okay. When you were talking about some of the things we should stop doing, one of them was blocking IP addresses, and a question came in that said, do you support dynamic blocking from various third-party feeds?
Yes, absolutely we do.
All right, cool. There's another question about the WAF policy that you're running on premises. Can you also run that on the AWS WAF using a different software version?
So you would not be able to run an on-premise policy in the AWS WAF, but you would be able to run an on-premise policy from an, like an F5 WAF on an F5 WAF in AWS. So again, we want to make sure that distinction that AWS has their WAF solution and F5 has a partner or peer WAF solution, which is what we're talking about when we discuss that policy portability. So if you're running F5 WAF in AWS, then yes, you can move those policies to on-prem, to another cloud, to your virtual environments, what have you, and vice versa.
Sure. There was a couple of different people asked, like, what was the main differentiator between the F5 WAF and AWS WAF? I think people would like a little more detail there.
So the AWS WAF, my understanding, and please correct me if I'm wrong, it's more of like a high volume. It's more kind of like a high volume solution where we don't have as much full like session tracking, things like that. So whereas in the F5 WAF, we have visibility over the entire session and we maintain visibility over an entire session. So we can do things like try to figure out over time whether a client is a bot, whether or not there's a human interaction being done with that, whether or not there's ultimately, say, fraudulent transactions being performed on a, like in the background, for instance. We also have a lot more active and interactive defenses, things that we can like do such as JavaScript injection to trigger certain events in browser, look for browser-based malware, etc. So I don't know, Nick, if you wanted to try to address some of that, but we feel
we created the AWS WAF because there wasn't like just a dead simple WAF on the market. It was most of them you have to set something up. It takes a little bit of time. Our WAF, if you have a load balancer or a CloudFront distribution set up, you can just turn it on, click a couple check boxes. So if you want like basic SQL injection, basic, there's a couple check boxes, and they're mostly black box. You can't really see exactly how they work. But if you just want to try to do something with best effort, the WAF, it's API driven. It's it's pretty cheap. So it's probably not going to to be like the top rated WAF in the Gartner Magic Quadrant this year or anything like that. But it's something we wanted to provide to customers to make it easy to get started with WAF. That's the way I would categorize it. And then if you want to go a little further, you can add F5 rules. If you want to go further than that, you can use the full-blown F5 WAF client. That's
sure.
what I would use to tell customers.
Okay, no, cool.
Let's see here. So how does a WAF fit into the framework of like IDS, IPS, SIEM, firewalls? Does it replace any of those things, or is it just adding to it? What's your general? I'll give you my general opinion is, in some cases I do see it replacing firewalls if the majority of your workloads are web applications. You may still, because the WAF is also not generally going to inspect non-web application points. So if the vast majority of your traffic is web traffic, then the WAF might replace some next-gen firewall sort of functionality. But you still have a SIEM for events, and you'll still probably have potentially IDS, IPS for sometimes that's a compliance requirement. So I don't know if you have a different opinion there.
No, I think that's pretty much on point. So it's a fairly specialized tool in that it's really for helping to protect the inbound traffic for the applications that you host that are public facing or end user facing, right? So like WAF is not something that you would use to manage like outbound requests from clients at desktops inside of your corporate network. But it is something you would use to manage the requests coming into your website or your application or your customer-facing service from the internet. So it's definitely complementary with respect to things like SIM, as mentioned, for particular use cases. Yeah, if you've got in your VPC simply web applications, then yeah, you probably don't need a next generation firewall to look at that traffic, since you're only allowing in port 80 and 443 anyway. What you need is something like WAF to inspect the actual requests and transactions that are coming in over that channel. So yeah, I think you're right on.
Cool. And there were some questions about the pricing in terms of what the pricing looks like. So at least on our side, like there's different ways to do the rules. So there's the web access list and rule changes. And then there's also a cost per million web requests. And then if you have managed rules, basically there's an additional cost for the managed rules on top of that as well. And if for the WAF appliance itself, you can get it sort of two major ways. You can get it off of Marketplace, which there's what the good, better, best, I believe, sort of licensing model, where there's different prices for those things. You can pay that by the hour if you want to kick the tires. You can also bring your own license if you wanted to get like a yearly or multiple year license, or you have something or licenses on premises that you want to try to use. You can do the bring your own licensing model for the full AWS WAF as well. So if you just do a search for like F5 AWS Marketplace, or if you go in and try to create EC2 instance, there's a little Marketplace tab where you can search for solutions there too. I don't know if you guys want to add anything to that.
No, I think that covers most of it.
Yep.
Do you guys have any demos of this working anywhere?
I mean, like videos of it,
yeah,
people deploying it. I mean, I think there's some stuff on YouTube. We have got some stuff in our own kind of like courseware, where if you're a customer, we have our F5 University, where there's a bunch of resources. So another great place to check is always Dev Central, which is an F5 development or a developer community and user community for people using our solutions, which we've got lots of folks on there that post questions about how to deal with certain types of attacks, how to build certain types of rule sets, etc. So it's a great community-oriented resource for F5 customers for sure.
Okay. Let's see here. So how does the F5 WAF inspect encrypted traffic?
How is it inspecting encrypted traffic?
Yep.
Well, so the way it works is you have your SSL certificate and key on the F5 WAF, and when a request comes in, we negotiate the SSL session between the client and the F5 device. And once we've done that, we basically act as a full proxy between the client and your backend infrastructure. So from there, we can do any, like application layer inspection. We can modify requests. We can reroute them. We can redirect them based on certain criteria. We can do like challenges to make sure they're not bots. But yeah, really, it just requires that you manage your SSL, your TLS key pair on the F5 device. So.
Okay, cool. Yeah, I'm just going to be putting a link out here because some people are asking about some more marketplace details. So let's see here. We'll do one more question because I think we need to wrap up here. Are there any migration tools for F5 physical appliances to either the virtual appliance in AWS or the AWS WAF?
Any migration tools? Well, we've got lots of ways to manage the configs. Lots of customers manage them in kind of atomic ways. So we have like our UCS, which is basically a config you can export from the device. But we also have full REST API access to really the entire configuration. So you could use the API to export certain parts of the config and then import those into different devices. There's really a number of ways to do that, certainly.
Cool. All right. Well, I want to thank everyone for joining. I think this is pretty productive. I think we had some good questions come in. Thanks, Dave and Nathan for joining us here, and hope you guys all have a good rest of your day.
Great. Thanks, Nick.
Awesome. Thanks, guys.